Hello, good day. This is Patrick Coulson here. Welcome everybody to this webinar, The Future of Tank Terminals in the Energy Transition. Hopefully this will be an interesting session. Ricardo, our host, has already posted some housekeeping rules. You can see that in the chat box. Main thing is that please keep your questions until the end. Well, you can write them during the session, and Ricardo will send an update and a summary to me, and I will handle them at the end. Okay, let's start. I think you can see my slides. Let's go for first. My name is Patrick Coulson. I am the Managing Director of Insights Global. Insights Global is a market intelligence and technology company. Our focus is on energy and chemical markets, and we want to create better energy and chemical markets by enabling intelligent decisions through our insights and tools that we provide, through market transparency, to support our client decisions making. If you want to see more on this, you can visit our website, insightsglobal.com and tankterminals.com. Just an overview of the various products that we offer. So we provide data services, analytics, consultancy, training services, and our online platform, tankterminals.com, where you can find all the terminals globally, all kinds of informational capabilities, location, infrastructure, and logistical performance. So tankterminals.com is a market research tool. It also has a terminal marketplace where you can offer, bid, and transact storage. And there are some operational tools to assist the terminals in vessel clearance and digital ISGOT 6 forms. Okay, back to the webinar. So the subjects of today, how to adapt your terminal to the energy transition. We will handle that subject according to these different stages. First of all, we will go into depth on the dual challenge that is very relevant for our industry. Then we will go into detail on how the energy transition is organized, our vision of the future energy system, and the implications for the liquid bulk markets. Then at the end, we will have the Q&A session. Okay, so the dual challenge, decarbonization and the plastic waste problem. Now, obviously, you've heard of climate change, and within the UN, countries are working together to limit the impact of greenhouse gas emissions. And the goal is to limit the emissions and to stay beneath 1.5 degrees centigrade rise in average surface temperature by the end of this century. And well, one of the major, actions to take is to reduce emissions. On the other hand, we also have a plastic waste problem. So there's a lot of plastic waste that is floating in the oceans. Everybody has heard about the plastic soup in the Pacific, but it's obviously a big problem, and it also impacts the terminal industry because a lot of the petrochemicals that are used to make plastics go through terminals. So in one way or the other, we are either part of the problem or part of the solution. I think this is the sort of the the disaster in the making. You have the plastic soup in the ocean. and the ice melting on the North Pole in this case. And well, you see the last polar bear floating around in the ocean full of plastic. Now, obviously, we want to work together to prevent this disaster from becoming reality. Now, one of the ways that people are working together is through the UN climate change conferences. Now, the last one was held in Dubai, and well, each country is committing to a path to reduce their emissions and to contribute to a net zero society. Now, currently, if you look at the countries around the globe, there are different levels of actions that are taken by countries, and well, you can see that there's a lot of work to be done to limit emissions, and well, a lot of countries are not on track. This map shows you which countries are on track and which are not, and well, it's hard to spot any countries that are really, let's say, on track. Most of them are either doing taking action which is, well, at most almost sufficient, but almost none of them really really do, and a lot of them are actually critically insufficient. So a lot of work to be done. Now, if you look at the US and the EU, EU's climate policies, in the US there is the Inflation Reduction Act, which is the most significant piece of US legislation to drive climate action. And in the EU, you have the Green Deal and the Fit for 55 package that are sort of the cornerstones for that, driving the climate change and driving emission reduction. Now, on the other hand, this legislation is also it also has in it political risk, because on the one hand we have this common goal to reduce emissions, but on the other hand we also are in a race to get the, let's say, green industries and technology developed in the specific countries, either Europe or the US or maybe China for that matter. And there's sort of a tendency to become more protectionist in this area. So it's driven by policies. A lot of demand is actually not market driven, but policy driven, and that creates a high degree of political risk. So you need to be very aware of policies and legislation, and it can change. It can change overnight. For instance, if the outcome of the U.S. presidential election is likely to have quite a big impact on the, let's say, the route the U.S. will take on this matter. Okay, so decarbonization. What does this mean? How to reach carbon neutrality in 2050? Now, the likely implications for decarbonization are that there will be less fossil fuel consumption to reduce CO2 emissions, more renewable energy sources, electrification of many sectors because it's more efficient and easy to decarbonize. Hydrogen is likely to become a key energy carrier and feedstock used in the industry, and e-fuels will be used to decarbonize the maritime and the aviation sector. Okay, so less fossil fuel consumption. Let's look at that for a moment. Now, in the various scenarios, and these are the, let's say, the scenarios that calculate and estimate the impact of the various energy transition routes up to 2050, and what's the impact on global petroleum consumption. Now, these, you can see three scenarios that run up to 2050. And the first, the top one is the stated policy scenario from the International Energy Agency. And it more or less results in a plateauing petroleum demand that is around current levels, around, let's say, 100 million barrels per day. Now, you have the announced policies scenario that takes into account the promises of the various, let's say, countries across the globe, but those promises, in some, well, in a lot of cases, they haven't yet been translated into actual laws or policies. So in that case, you will have a reduction to 55 million barrels per day. And then the last scenario is the net zero emissions scenario. And even in that case, you will still end up with 24 million barrels per day of oil consumption. So even if we manage to get to a net zero point in 2050, then still petroleum will still be relevant. It will be reduced, and let's say in the most extreme scenario, to a quarter of the current demand, but still sizable. So please keep that in mind. Now, it also matters in which part of the globe you're situated. So the Western economies will reduce demand, dependent obviously on which scenario becomes reality. But in those regions, the consumption of petroleum products will reduce more than compared to other parts of the world. You can see that in this chart. And the same applies for natural gas. So natural gas in the stated and the step scenario will remain around current levels, and also in the app scenario it will be reduced. So same picture here, but it won't go to zero. So important to keep that in mind. Now, more renewable energy sources. So here you can see, the various sources of renewable energy. So hydro energy, solar, wind, tidal, thermal, and biomass. The most promising solutions take solar and wind energy as a source, because those types of energy can scale the most easily way. And well, talking about scalability, biomass has limited scalability because, well, if you sort of calculate and would try to replace the current energy consumption with biomass, well, you need like 5 planets or something like that. So that's not a solution, but solar and wind energy can scale to a size that is able to replace the current fossil fuel energy sources. However, both solar and wind are so-called intermittent energy sources, which means that it's not always there. Obviously, when the sun goes down, you cannot get solar energy, and when the wind doesn't blow, well, there's no wind energy. So you need to you need to create a energy system that is able to cope with that. Now here you can see that, so there are both seasonal patterns in solar and wind energy, and there are also differences depending on where you are on the planet. So, for instance, in the Sahara Desert, there's a lot of solar energy, which is very efficient to generate there, compared to, for instance, Scandinavia, where the sun doesn't shine that much, or it is very cloudy. Now, if you look at the, let's say, the future of a low carbon power market or energy system, for instance, in the EU, there are currently two scenarios. So the first one is the full renewable scenario, which is sort of pushed by the European Commission. And that sort of, the aim there is to replace, let's say, fossil fuels with an energy system that is fully dependent on either wind or solar energy in most cases, as sort of the backbone of the energy and power generation. That's one scenario. The second scenario, and this is sort of becoming more popular, is what I call the nuclear option. To create more nuclear power plants to generate electric power, which can be used to drive the economy. Well, the difference obviously between full renewables and nuclear power is that, well, as I said earlier, renewable energy, wind and solar, is intermittent power, and by nature much more unstable compared to nuclear power, which is more or less dispatchable power, and well, you can sort of vary the nuclear power output to match the demand for power, which is much easier to manage. The drawback is that well, recent nuclear power plants and projects are quite notorious because they encounter a lot of delays and suffer from budget overruns. And well, nuclear power by nature is not renewable because it uses fuel in some way, and nuclear fuel. Okay, so if you look at the renewable energy system design, it should look something like this. So you have a lot of renewable energy generation by wind and solar. On the one hand, you have demand on the other hand, and you need some mechanisms to balance power generation with power demand, either batteries, for short-term storage, or you need some sort of mechanism for long-term storage to cope with maybe cloudy weather, or weather when there is not so much wind, to bridge that sort of period. Also for seasonal variations in power demand. So in the winter you need, let's say, the most of the regions you need more power to heat homes and offices, etc., compared to the summertime. So there's also a seasonal, let's say, demand fluctuation. So in that case, you need some sort of long-term storage solution, and it can be either hydrogen or flow batteries or whatever. So there are a couple of solutions for that. Now, electrification of many sectors is seen as a solution to decarbonize. And well, the current consensus is that, let's say transport sector, so personal vehicles and heating are relatively easy to electrify. I think now also the trucking is most likely to be electrified. But if you look at the aviation sector, maritime sector, and industry, where you need high temperature process heat, those areas are hard to electrify and still require some sort of fuel. Now, hydrogen is seen as a solution for those hard to electrify sectors. It's also seen as an energy carrier that can be stored and transported in one way or the other, either liquefied hydrogen, ammonia, or methanol, or via liquid organic hydrogen carriers. Hydrogen can be traded, transported, stored. Now, this is an example of various projects that are using hydrogen in the port of Rotterdam. Now, it's important to underline that hydrogen is not always the best solution, and it's not a one-size-fits-all solution. So, this hydrogen ladder sort of visualizes the various use cases and its relative competitiveness. Now, at the top, the A label, it means that these use cases are very competitive because there is either no alternative or it makes really sense. So, for instance, fertilizers or hydro generation or hydrocracking at refineries use hydrogen as a feedstock, and there's basically no alternative to decarbonize those sectors. The same applies for methanol. And going down, so on the other hand, least competitive, it's just not such a good idea to use hydrogen in fuel cells for, cars or something like that, or to produce e-fuels like e-diesel or something like that. It makes much more sense to go to a battery electric vehicle solution for those sectors. A nice picture. So e-fuels to decarbonize hard to electrify transport modes. Heavy-duty trucks. There's some debate on that. Looking at the current situation, I think it makes more sense to electrify those heavy trucks. But shipping and aviation, it does definitely make more sense to use e-fuels in those sectors. So aviation and sustainable aviation fuel, which is either made from bio material like vegetable oils in the hydrogenated vegetable oil process, or the e-kerosene route. Now, shipping, methanol, and ammonia are, let's say, two alternatives to decarbonize shipping. So conclusion, if you look at the energy markets, you can sort of split the various products in losers, and winners, and losers, which I mean the product markets that are likely to have a downward trend in volumes. The biggest loser, I think, will be gasoline, because gasoline is used mainly for passenger cars. Passenger cars are quite easy to electrify using battery electric vehicles. Same applies for diesel, although I think the trucking will stick to diesel for a slightly longer period, so that will take a longer period to go down in volume. Fuel oil used in shipping currently. The maritime sector won't be the first sector to decarbonize. It will probably take longer for all the ships to change to either ammonia or methanol. Natural gas for heating and for industry is going to lose, let's say, market share. Jet kerosene, sooner or later will go down. Rather later than sooner, I would guess, because of the, let's say, conservative nature of the aviation sector, and because of the availability issues for sustainable aviation fuel currently. And last, hydrocarbons for the petrochemical industry. Now, you might argue that hydrocarbons for petrochemicals is not a fuel. That is true, but still, if you due to recycling, and I will come to that in the next slides, there will be a downward trend for hydrocarbons in that sector, let's say virgin hydrocarbons. Now, the winners of the energy transition, most of all electricity, but that's not a liquid, so you cannot store that in a tank. Hydrogen, that's the second one, but that's a gas. But in a lot of cases, to transport hydrogen, you will convert it to a hydrogen carrier like ammonia or methanol, or maybe store it in a liquid organic hydrogen carrier. So still that will provide some opportunities for terminals. E-fuels like methanol, ammonia, e-kerosene, and biofuels, and sustainable aviation fuel made from vegetable oils. Those will probably go up in volume. Okay, so that's the energy side. Now let's go to the more chemical side, the plastics. Again, there is a big problem currently with plastic wastes. There are two sort of routes to tackle the plastic waste reduction problem. First of all, recycling. Currently, there is a lot of recycling, but the problem is that, if you recycle, you need to be very careful not to mix up the various plastic, let's say, types. So a way to tackle that is to apply a so-called process called molecular recycling of hydrocarbons. So that's one solution, and the second one is production of biodegradable plastics. So when you throw that away and it ends up in, let's say, the nature or in the environment, that it doesn't last forever, but that it sort of decomposes and in the end is biodegradable. Now, first of all, molecular recycling of hydrocarbons via pyrolysis. You can make a sort of a naphtha-like liquid that you can feed into a steam cracker. Now, here you can see some sort of samples of what that looks like. One of the things is that depending on the mix of plastics that you sort of recycle in this process, you end up with different grades of naphtha-like liquids. So that's interesting because you need a lot of different tanks to segregate all those different grades. So that's one way to tackle this problem. The other way is the biodegradable plastics, and well, we've looked into this, but I think the conclusion is that currently there is not a this is not the solution yet because it has all kinds of issues. It's expensive. The scalability is an issue, and the quality of the plastics is not according to normal standards. So the conclusion is that there is still a long way to go. Now, if you do the same exercise, you try to figure out, okay, which products are likely to go down in volume and which are likely to go up in volume. Then the conclusion is that hydrocarbons for steam crackers from petroleum are likely to go down because there will be more recycling. So, if the end demand stays the same, then obviously there will be less feed in from petroleum refining, from naphtha or let's say natural gas liquids. Now, the winners will be hydrocarbons from recycled plastics, and already you see some announced projects to recycle, to build installations that recycle plastics, and you get some sort of reverse supply chain process from small, let's say, sites that recycle the plastics at the different locations and then ship it and make bulk and in the end ship it to the big steam crackers to feed in. Okay, so that's sort of the conclusions on the one hand for the energy market, and on the other hand for the plastics and the chemical market. Obviously, there is a lot more to do with how to prepare for the energy transition, and there are a couple of ways to follow up. So we are organizing energy transition training that will go into much more detail on all kinds of subjects like emissions trading, power markets, hydrogen, etc. So it might be good to understand all the implications of this. There's also a possibility to do a energy transition workshop where we also go into details on what does the energy transition mean for your terminal or your business, and how can you adapt to this changing environment. And there's also an energy transition update, sort of a periodic update on news and analytics, etc., to keep you up to date with the latest developments. Now, if you're interested, please contact me. You can find my phone number and email address on this slide. So don't hesitate to do that. And hopefully this session was interesting. And if there are any questions, then please put them in the chat box, and no, our host Ricardo will send an update to me to answer. I'm just looking at my WhatsApp and just going through the various questions. Now, first question from Ernie. What do you make of the news that Hertz Global is selling 1/3 of their electric vehicles and will be replacing them with fossil fuel-driven vehicles? Okay, so that's the Hertz is the car rental company, and apparently they're selling 1/3 of their electric vehicles and replacing them with fossil fuels. Well, I guess battery electric vehicles still have a way to go. They're not perfect yet. Maybe especially not for these car rental companies. And yeah, I'm not how do you say that? I don't. From this information, I don't know exactly which region, but yeah, if the infrastructure is not sufficiently developed, and that is an issue in a lot of countries. So if you cannot reload your battery using superchargers, it's kind of a hassle to drive electric vehicles. So developing and making the infrastructure ready, and the rollout of electric vehicles need to go hand in hand. So that's definitely something to keep an eye on. Okay, so another question from Peter. Will electric vehicles win over fuel-driven vehicles? I think in the end it will, because, we are trying to decarbonize and to prevent global warming. So if we like it or not, it needs to be done sooner or later, and that's the only way. Or we need to accept that temperature will rise. Another question: what do you think of all the NYMEX tankage in New York Harbor being torn down? Will the NYMEX delivery point be under-tanked? Yeah, I don't see the sort of the relevance for the energy transition, but that's my first take on this is obviously there might be a risk. We've been in backwardation for a long time, so there's less demand for tank capacity. But yeah, if that market will change structure, then there might be an issue. Another question. So 3 points. Charles mentioned these questions. So the International Energy Agency, point 1, is not a forecaster. Its data is based on given inputs into its model. Each scenario is not a forecast of what will be realistic. Well, there's obviously a lot of debate on forecasting, and by definition, nobody can forecast the future, because the future is very, let's say, dynamic and volatile. So it's more, it has to be seen as a sort of an exercise. Anyway, you need to do, be able to see, to sort of visualize the impact of policies, and I think that's the purpose of those forecasts. But yeah, it's not a given. It's not certain. That's why they have multiple scenarios, and I just showed you the ones from the International Energy Agency, but well, if you look at the forecast from OPEC or from other organizations, then there are quite big differences. Okay, going to another. So the second point, electrifying transport systems does not decarbonize the atmosphere unless all electricity is generated via non-carbon means. Yes, that is true, but electric vehicles are more efficient from an energy point of view. So even though they, let's say, do not have full, are not fully fossil free, there is already a, let's say, a benefit of that. And yeah, countries around the globe are working to increase the share of renewables versus fossil fuel power generation. But yeah, there is a, let's say, still a way to go. Third point, the EEA, the International Energy Agency, gives no forecast of the impact on the planet of all the mining needed to produce the metals to allow the storage of intermittent power. Yeah, that's true. That's an issue. Yeah. So the batteries, they need a lot of metals like lithium. But there are different ways. You can also use flow batteries or other ways that do not use these kinds of metals. Another question. What are your thoughts on the current production cuts from OPEC and the product prices? Is there no correlation to be found anymore as it used to be? Yeah, that's a specific supply and demand question for the oil markets. If the market is tight and OPEC cuts production, then well, the balance will the increased shortage will likely result in higher prices. That's not the case at the moment, apparently, because there are, say, doubts on future demand, if that will keep on rising or not, or maybe decline. Okay, another question. Are terminals already preparing for the future? If not, what are the main hiccups? Yes, I think a lot of terminals are looking at the energy transition and trying to adapt to that. So they're looking at the business development projects to adapt to the energy transition and trying to develop projects in for instance, hydrogen import or make bulk operations for instance, that renewable aviation fuel, sustainable aviation fuel, or recycled plastics or something like that. So that's definitely happening at the moment. There are problems, and that has to do with the legislation side, or that, for instance, in case of hydrogen, that the consumers are sort of lagging behind, or maybe not taking the decision yet to postpone, because there are also affordability issues. So hydrogen currently is just too expensive to replace natural gas. Okay. Next question. What about LNG and the methanol supply of vessels and barges? Is this part of the green energy transition? Well, methanol can be decarbonized. You can make sort of green methanol using hydrogen and using biomass. So that's possible, and yes, that is part of the green energy transition. LNG, strictly speaking, not, because it's made from natural gas, which is a fossil fuel. But yeah, if you compare it to petroleum, to fuel oil, there are some sort of emission benefits, because it has less CO2 emissions per energy content. Okay, so yes, I think I'm through the, let's say, the questions, and would like to sort of end this session. So thank you very much for the attention, for participating, and for posting all the questions. As Ricardo said, if there are any remaining questions, you can also email me, and we will follow up on that. Okay, well, thank you very much, and hope to be in touch. Bye bye.